Okay, Assalamualaikum and good morning. Okay, please slide in your attendance. We will start soon. Okay, Assalamualaikum and good morning. We will start now. Okay, last week we learned about AC power. So, if in DC there are only a little bit about power, but for AC there are multiple power quantity. So you need to know how to get everything. Okay. So here, today I will show you some example. Okay, 2 example for using the power. Okay, this is the first example. Okay, you can get this from the slide. Okay, determine the power factor of the entire circuit as seen by the source. Means that what is the power provided by the source. Okay, so first thing, of course, you have to know what is the equivalent impedance. Okay, ZEQ. Okay. So first, okay, this one and this one is in parallel. Okay. So negative J2 parallel with 4. Lepas tu negative J2, okay, for negative J2 plus 4. Plus 4, okay. So, wait. So negative 28J divided by 4 minus 2J. So use your calculator to get the answer. So you get 0.8 minus 1.6 J. Okay. So remember the complex power. So complex power is, you can use either way. You can use the P equals to VI cos theta, or you can use a complex power. I suggest you use complex power because it is a much more easier approach. So remember, as the complex power, to show the complex power, you just bold it. Okay, the easiest way. Okay, then you have a impedance. You have a voltage source here. You have an impedance. Okay, so just use the formula V. Okay, V squared. V is the magnitude only, divided by, okay, Z equivalent. Okay, which is this. Sorry, we still not finished the Z equivalent. Okay, so this is just a parallel one. So after that, you get this. Then Z equivalent is equal to 6 plus 0.8 minus J16. Okay, in series. So this one in series with both of this. Okay, so equals to 6.8 minus J1.6. Okay. Then after that, you can use a complex power. So complex power is actually much more easier compared to other formula. So make sure you bold it, okay, to show that it is a complex power, equals to, because you have Z equivalent and voltage, okay, so you only use the correct formula, which is V squared divided by ZEQ. Don't forget conjugate. Okay. So V squared, okay, V, you don't need to include the degree. Okay, make sure you remember that. Okay, if there is Z in the complex power, don't use the angle. So basically, this one is 30. Okay, 30 squared. Okay, divided by Z equivalent is 6.8 minus J.16. So because this is conjugate, okay, so plus. Okay, so this one you have to change. Okay, you have to flip it. So insert into your calculator. Is squared divided by 6.8 plus 1.6 J. Okay, so you get, okay, 125.41 minus 29.51 J. Okay, okay, the unit is VA. Okay, for complex power, I suggest you put both. Okay, both format, rectangular form and polar form. So for polar form, okay, so also equals to, okay, 128.83. Okay, the angle is negative 13.24. Okay, the unit also in VA. Okay, why in complex power I suggest you put both? Because you can extract many things from these two. Okay, so if from here is basically S, okay, equals to P plus JQ, okay, real power, reactive power, and also complex power and the angle. So that's why I suggest you put both. Okay, you have to put both. Okay, because the question asks what is the average power delivered to by the source, means that it is real power. Okay, if they said it is average power, it means that real power. So P equals to, so from this you can just directly take from here. Okay, so P equals to 125.41 watt. Okay, and how about the power factor? So power factor actually you can get from this one. Okay, the angle. Okay, so power factor P dot F dot equals to cos theta. So just cos, you take the value here, okay, cos negative 13.2, okay, equals to cos 13.24, okay. Okay, wait, cos 13.24. So the power factor is 0.7, 0.97, okay. And remember I said before, this is negative, right? So negative means that it is leading. So when you write power factor, make sure you mention the lead or lag. Okay, for this case, if it the angle has negative, means that it is leading. Okay, so power factor is 0.97 leading. So you get the answer. Okay, so that is the first example on the power. Now we look at the second example. Okay. Yes.
I have a question for the last question.
Okay.
Can I see the solution?
Okay, which one?
The The complex power, to calculate the complex power by using the voltage and the impedance, but we
Yes.
don't need to put the angle, because I think last time the last video got,
Okay.
got use the angle.
Oh, I mentioned in the last video,
Mm,
anytime you have square, don't put any angle.
okay.
Yeah, if there is no square, you can put the angle. If there is square, don't put the angle.
Okay, thank you, doctor.
Okay, welcome. Okay, so we look at the second example. Okay. So calculate the average power and reactive power, okay, at the terminal of the following network. So you have V and I. Okay. So this one, okay, you can either use the P equals to VI cos, okay, cos theta V minus theta I, okay, or okay, I just show you both way. Okay, the first way is use this way. Okay, so VI is 100 for, oops. Okay, to use this formula, okay, wait, where is it? Okay, sorry, the note is not too complete. Okay, it's okay, I just show you. Okay, first thing, okay, sorry, first thing, if it is in the time domain, make sure you change it into phasor domain. Okay, so V equals to 100 divided by square root 2, and the angle is 15. I equals to 4 divided by square root 2, the angle is negative 15. So make sure you change this first before you use the formula. So I show you two ways to do this. Either you use P equals to V I cos theta V minus theta I. Okay. So this one just take the 100 divided by square root 2, and then 4 divided by square root 2. Okay, the magnitude only. Cos, okay, theta B is 15 minus 15. Okay, so use your calculator. Okay, and make sure this one is in RMS. Make sure the P you use this one is RMS. If you use magnitude, okay, if you use magnitude, you can use this formula also, but make sure you divide by 2. Okay, P V magnitude I magnitude divide by 2. Okay, cos theta V minus theta I. So be careful when you use this formula. Make sure you use in RMS, or if you use maximum, make sure you divide by 2. Okay, so 400 cos 30. Okay, the P is 346.411 watt. And reactive power, which is Q. Okay, Q also use the same formula, RMS. Okay, I RMS, not cos but sin. Okay, sine theta V minus theta I. Okay, so take the magnitude only, 100 divided by square root 2. Okay, then multiply by 4 divided by square root 2. Okay, sine 15 minus 15. Okay, so use your calculator. So Q equals to, so you get 200 bar. Okay, for Q the unit is bar. Okay, state that if the power is absorbing or deliver the real power. Okay, if you can see here, it is positive. Okay, P is positive. So real power is absorbed. Okay. So how about Q? Q is also positive. Okay, when Q is positive, means that the power, reactive power, is also absorbed. Okay, if Q is negative, means that the power is delivered. Okay, so that is the first way to do this. Okay,
Doctor,
how about yes?
sorry. Why we no need to change the V and I into the same cos or same sign?
Sin cos, which one?
The V equal to the question. The question
Okay,
given V equal to 100 cos.
okay.
And then the I.
Oh, sorry, I don't see it. Sorry. So for this case, you have to change it. Okay. So all of the calculation is wrong actually. So for this case, make sure you change it first. So be careful. Okay. So if you want to change this, okay. So cos, sine to cos means that. Okay. Remember C S. Okay. Plus if increase plus if decreasing minus. Okay. C to S, S to C. So for this case, sine goes to cos is minus 90. So negative 15 minus 90. Okay, so I equals to 4 square root 2. Okay, negative 15 minus 90 is 105. Negative 105. Okay, make sure you change it. So be careful. So negative 105. So this one is also changing. So 400 divided by 2. 200 cos 15. 15 minus plus 105. Okay, so you get negative of negative 100 watt, and for this case okay you get 173.21. Okay, so you can see here the power is negative. Okay, the power is negative. So the power negative means that the power is delivered. Okay, and for Q, okay, the reactive power means that because it is positive value, the power is absorbed. So be careful when you define this. So negative 105. So this is the first way to do this. Okay. The second method you can use is by using the complex power. Okay, so you can continue from this. Okay. Okay. But now instead of using the 1 by 1 power, okay, P equals to cos sin and Q equals to sin. Okay, instead of using that, you can use a complex power. So because you have V and I, so use V I. Okay, don't forget the conjugate. When V is present, okay, V is present, make sure you conjugate the other component. And since there is no square, there is you have to use both value. Okay, angle and magnitude. So 100 divided by square root 2, and then 4 divided by square root 2. Oh, sorry. 100 divided by square root 2 angle 15, then multiply by 4 divided by square root 2. Okay, angle is negative 105 degree. So use your calculator, or you can use it manually. Okay, so this one 100 divide by square root 2, multiply by 4, divide by square root 2. Okay. So for the angle, if multiply, you just add. If divide, you have to minus. So 15 plus minus 105. Okay, degree. So this one 200, angle is 90 degree, right? Let me check first. Okay,
Doctor,
conjugate, right? Yeah, so for conjugate, make sure you change this. Okay, if the value is negative, make sure you change it to positive. Okay, so this one is 15, 10, 20, 120 degree. So use your calculator. Okay, from this, remember that you are S equals to S equals to P plus JQ equals to S angle theta. So change it to the rectangular form. 200 angle is 120. Okay, so you get negative 100 plus 173.2 to 1. Okay, this one is J. So you can see that P is equal to negative 100 watt. Okay, so Q equals to Q is positive 173.21 VAR. So the answer should be the same. Okay, so it is the same. Okay, so we have complete the power. Okay, how to calculate power in AC circuit. So we will stop about 5 minutes. Okay, and we will continue with the next subtopic. Okay, take a break.
Sir, can you show the QR code?
Oh, QR. Okay, wait.
Thank you, Doctor.
Okay, welcome.